Welcome back to my channel. So before we start with our new session or new lesson for today, please don't forget to hit the subscribe button and the notification bell. So this is Teacher Dong. So the name of my channel is Teacher Dong. Don't forget to subscribe. Okay. So for this session, we're going to have triangle congruence. Alright, so we are going to talk about the different triangle congruence postulates, which we are going to use the congruence or to prove the congruence of two triangles. Alright, so for our first activity, number 1, we have match the following animals or matching type. So for the first column, we have dog, we have cow, we have kangaroo, we have lion. So we have to actually take the correct answers from the second column. A, Joey, B, Cobb, C, Poppy, D, Calf. Alright, so let's start with number 1, dog. So what do you think is the answer for number 1 among all the choices? Very good. It is letter C, Poppy. Okay, so Poppy is the baby version of a dog. Alright, so very good. Number 2, cow. What do you think is the baby version of a cow? What do we call it? Very good. It's letter D, calf. Okay, so thank you so much for those who are participating. How about number 3, kangaroo? What do you think is the baby version of a kangaroo? Very good. It's letter A, Joey. Okay, so for number 4, lion. So what do you think is the baby version of a lion? Okay, very good. It's a cub. Okay, so as you can see, in the second column, these are the baby version of the animals in the first column. Okay, so they are matched with the actually adult term for the animals that we're talking about. Okay, so we can say that dog is also a puppy and puppy is also a dog and so on and so forth. Okay, so what is the relation of this in our activity or in our lesson for today? So let's try to observe this bridge, okay, before we proceed. So as we can see, there are shapes that are actually present here. The dominant shape is a triangle. So as you can see, we have congruent triangles in this specific bridge. Okay, so there will be a question in the structural integrity of this bridge if the triangles are not congruent. Okay, so same as well with this structure, there are also congruent triangles. Okay, so we have the Ferris wheel. Of course, the Ferris wheel will not become in circle shape. Okay, so if the triangles are not congruent. Okay, that's it, right? So congruence means having the same shape and size, and of course the measurements. Okay, so when the two figures or geometric figures have the same measurements and the same size, therefore, okay, so we call them congruent. And congruent is a term that we are using to denote that two geometric figures are of the same size, shape, and measurements. Alright, so we cannot actually use it in saying that two numbers are equal. So in numbers, okay, we are using equal or equality, but when we are dealing with geometric figures or geometric figures with the same shape, size, and measurements, okay, we are using the term congruence or congruent. Alright, so and it is denoted by the symbol. Of course, it goes like this. So when you are comparing two geometric figures that are of the same shape, size, and measurements, okay, so we are actually using the congruent symbol. Unlike if we are actually comparing two numbers that are equal, we are using, of course, the equal symbol. Congruent symbol is only for geometric figures. Okay, next, congruent triangles. So when we say congruent triangles, two triangles are congruent if they are of the same shape and size. So just like what you are seeing, we have the blue triangle and then we have the red triangle. So if we're going to put them together, as you can see, they are of the same shape, size, and of course, what is common is that the sides or the segments are congruent and also the angles are congruent for us to say that these two triangles are congruent. Alright, so the other way around, two triangles are not congruent if they are not of the same size and shape. So if we're going to put together the blue triangle and the red triangle, So as you can see, the blue one is smaller than the red. Okay, so that's why they are not congruent. The symbol for corresponds to is this. Okay, so the one that you are seeing on the screen. That symbol is also being used for biconditional biconditional statements. Okay, all right. Now we have triangle ABC and triangle DEF. Right, so let's state the corresponding angles and the corresponding sides. So let's start first with the corresponding angles. For the corresponding angles, when we say corresponding, they must be of the same, they must be having the same measurements. So for us to call them corresponding angles or corresponding sides, right? So angle A corresponds to angle D. That's how you're going to read it. Again, so how are we going to say that two angles are corresponding angles if they have the same measurements? So just like what you are seeing, angle A and angle D do have the same measurement. That's why they are corresponding angles. Next, we have angle B, then angle E. We also have angle C and angle F. So we're done with the corresponding angles. Okay? So now let's have the corresponding sides. So for the corresponding sides, these are segments with the same measurements or that are congruent. So we have segment AB and segment DE. We also have segment BC and segment EF. And lastly, we have segment AC corresponds to segment DF. So that's how you're going to read it. Segment AB corresponds to segment DE. Segment BC corresponds to segment EF. Segment AC corresponds to segment DC. Okay? Next, we have triangle HIG and then triangle JKL. Okay? So let's actually have the corresponding angles and corresponding sides. Let's start with the corresponding angles. Angle I corresponds to angle L. Angle H corresponds to angle J. Angle G corresponds to angle K. So let's have now the corresponding sides. Segment HG corresponds to segment JK. Segment HI corresponds to segment JL. And segment GI corresponds to segment KL. So let's have the other set of triangles. We have triangle MNO and triangle PQR. So let's start with the corresponding angles. Angle N corresponds to angle Q. Angle M corresponds to angle P. And angle O corresponds to angle R. So let's have the corresponding sides now. So segment MN corresponds to segment PQ. Segment MO corresponds to segment PR. And lastly, segment NO corresponds to segment QR. So let's now talk about included side. So when the vertices are the endpoints of the segment, so we call it included side. So in simple manner, in a triangle, if there are two consecutive angles and then the segment that is being formed in between, okay, is what we call the included side. So example, angle H and angle U, okay, so the included side is segment HU. So I do hope that you can follow. Angle A and angle U, the corresponding side is segment AU. Angle A and angle H, the corresponding side is segment AH. Then let's have the other triangle. Angle L and angle O, the corresponding side is segment LO. Angle L and angle W, the corresponding side is segment LW. Then angle O and angle W, the corresponding side is segment OW. Alright? So that's it. Now let's have included angle. When the sides of an angle are two sides of the triangle. It's the other way around now. So when we say included angle, there are two consecutive segments of segments or sides of a triangle, and then the intersection or the angle between is what we call the included angle. Okay? So segment JT and segment PT, the included angle is angle T. Segment JP and segment TP, the included angle is angle P. Segment PJ and segment TJ, the included angle is angle J. Alright, so I do hope that you can follow. Then we have segment WT and then segment OT. the included angle is angle T. We have segment WO, we have segment TO. Okay, the included angle is angle O. And lastly, we have segment OW and then segment TW. The included angle is angle W. So that's what we mean when we are talking about included angle. Okay, so I do hope that you understand and you can follow. But if not, okay, so you can actually comment down for your questions, and of course, or you can actually send me a personal message on my messenger and on my email. Okay, next, let's have the triangle congruence postulates. So let's start the first one. Okay, but before we start, class, let's state first again the difference. Let's differentiate again, okay, theorems and postulates. So when we see theorems, okay, theorems, these are statements that needs to be proven before we accept them as facts or true statements. So unlike when we say postulate, postulates are universally accepted as fact. Alright? And we are using postulates to prove or as reasons to prove, okay, so the theorems. Okay, so that's it. I do hope that you know the difference between theorems and postulates. Okay, theorem needs to be proven before accepting as fact, and postulates, these are universally accepted as truth or fact. So it means that these are being used to prove theorems. Alright? So let's start with the first triangle congruence postulate. So we have SSS postulate. What do we mean by SSS? It means side, side, side postulate. So what do we mean by this? If the sides of the first triangle are congruent to the corresponding sides of the other triangle, therefore they are congruent under SSS postulate. That's just like what you are seeing here. Segment AC is congruent to segment OD. Segment CT is congruent to segment DG, and lastly, segment AT is congruent to segment OG. Alright? So that's why they are congruent under triangle ACT, and then triangle ODG are congruent because of SSS postulate. So we can say that the two triangles are congruent because of this postulate. Alright? That's it. Next, segment SU is congruent to segment RA. Segment UN is congruent to segment AY. And lastly, segment SN is congruent to segment RY. Okay, so we can say now that triangle SUN is congruent to triangle RAY because of side, side, side postulate or SSS postulate. This is now the conditional statement for SSS postulate. If three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. Again, three sides congruent to three sides of the other. Alright, so for us to say the two triangles are congruent. So this is the postulate under SSS. Okay? Name the remaining parts that need to be congruent so that the triangles can be congruent by the SSS congruence postulate. Segment CA is congruent to segment SE. Segment AT is congruent to segment EW. And then segment CT is congruent to segment SW. Alright, so if that's the case, we can say that triangle CAT is congruent to triangle SEW. Right? So I do hope that you can follow. So that's SSS postulate. This time, let's have SAS postulate. So what do we mean by SAS postulate? We have side angle side postulate. Alright, so what do we mean by this? If the two sides and the included angle are congruent to two sides and the included angle of the other, therefore the two triangles are congruent. So just like what you are seeing here, segment CA is congruent to segment DO. Then angle A is congruent to angle O, and segment AT is congruent to segment OG. That's why we can say that these two triangles or triangle CAT is congruent to triangle DOG because of SAS postulate or side angle side postulate. Right? So let's prove that triangle QRT is congruent to triangle QST with SAS postulate. Alright, so segment RS is congruent to segment ST. Then segment RQ is congruent to segment TQ, and angle R is congruent to angle T. So therefore, we can say the triangle QRT is congruent to triangle QST under SAS postulate. Let's have the conditional statement of this postulate. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. Again, two sides included angle of the first triangle must be congruent to two sides and the included angle of the other triangle for us to say that two triangles are congruent under side angle side postulate. Alright? Name the remaining parts that needs to be congruent so that the triangles can be congruent by the side angle side congruence postulate. So segment QR is congruent to segment QT. Segment QS is congruent to segment QS. Okay, so why are they the same? It's because it's a bisector and it's a common side of the or common segment of the two triangles. That is what we call reflexive postulate. And of course, we have angle RQS is congruent to angle TQS. Okay, so these are the two angles that are included. Right? Next, let's have the ASA postulate. So if in the previous postulate we're talking about included angle, this time let's talk about included side. Alright? So, what is angle side angle postulate? So as you can see in this example, angle C is congruent to angle D, segment CA is congruent to segment DO, and angle A is congruent to angle O. Alright, so if that's the case, you can see that there is an included side between the two angles. Alright, that's why it's what we call angle side angle postulate. So we can say now that these two triangles, triangle CAT and triangle DOG, are congruent because of angle side angle postulate. So other way around, okay, so if we have angle A congruent to angle O, segment AT congruent to segment OG, and then angle T is congruent to angle G, so they are congruent under ASA or ASA postulate. Angle M is congruent to angle R, that's the first angle. Angle A is congruent to angle E, that's the second angle. And then, of course, the segment or included side, we have segment MA congruent to segment RE. Alright, let's proceed. Therefore, we can say the triangle MAY is congruent to triangle REY. Let's state the congruence or the conditional statement of ASA postulate. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. Again, we are talking about two angles, included side, congruent to two angles and included side of the other triangle. So name the remaining parts that need to be congruent so that the triangles can be congruent by ASA congruence postulate. Angle B is congruent to angle M. Angle T is congruent to angle T. Alright. And segment BT is congruent to segment TM. So we can now say the triangle BAT is congruent to triangle MAT. Now let's have the last one. We have the SAA or AAS. Okay, so we can say SAA or AAS postulate. So what is this? Okay, so we have angle side postulate. So what do we mean by this? Two angles and then the side opposite to one angle. Alright, so as you can see, we have two consecutive angles. Angle C congruent to angle D, angle T congruent to angle G, and opposite to is T or angle T is segment CA, and opposite to angle G is segment DO. Alright, so that's it. So if these three pairs are congruent, therefore we can say that triangle CAT is congruent to triangle DOG under AAS postulate. So other way around, we have this. Angle C is congruent to angle D. Angle T is congruent to angle G, and the side opposite to angle is segment AT is congruent to segment OG under AAS postulate. So let's prove using AAS postulate the congruence of triangle ABC and triangle DEF. Segment, angle B is congruent to angle E. Angle A is congruent to angle D. Then segment BC is congruent to segment EF. Alright, so that's why we can say that triangle ABC is congruent to triangle ADEF because of AAS postulate. So let's have the conditional statement of AAS. If two angles of a triangle and a side opposite one of its angles are congruent to two angles and a side opposite one of the angles of another triangle, then the two triangles are congruent. Again, we are talking about two angles, side opposite, two angles, side opposite. Name the remaining parts that need to be congruent so that the triangles can be congruent by the AAS congruence postulate. So angle Y is congruent to angle V, then angle YXZ is congruent to angle VXZ, and then segment YZ is congruent to segment VZ. So that's why the two triangles, triangle XYZ and then triangle XVZ, are congruent. Now, in relation to AAS, we have the CPCTC, or the corresponding parts of congruent triangles are congruent. So this is in relation with AAS and the other postulates, alright? So we can use this postulate, okay? That when we are actually having have corresponding parts of congruent triangles, they are automatically congruent under CPCTC principle or postulate. Now, let us use those postulates in proving the congruence of triangles. But before that, please remember the following. So these are theorems, or rather, these are postulates that we can use as reasons or as proof, okay, of the statements. Again, these are postulates. Alright? Other than the postulates that we discussed, these are premises that we can use so that we can prove the congruence of triangles with a specific postulate, as SS, ASA, SAS, AAS, or CPCTC. First is an angle bisector forms two congruent angles. Alright, so if we have the triangle here, then we have the angle bisector. All of the angles formed are congruent. A midpoint of a line segment yields congruent line segments. So same thing, if we have a triangle here and then we also have the bisector, and then let's say this is the bisector, this is the midpoint, therefore we can say that these two segments are congruent. Perpendicular lines form right angles that are congruent. Okay, so let's say these are two perpendicular lines. So all of the angles formed at the intersection are right angles. That's what we mean by that. Parallel lines give the following pairs of congruent angles. So alternate interior angles are congruent, alternate exterior angles are congruent, and corresponding angles are congruent. So what do we mean by this? So if we have parallel lines cut by a transversal, so this one is a transversal, these are what we call the alternate interior angles. They are congruent. So we have two pairs. Then we also have the alternate exterior angles that are congruent. Alright, so there are also two. Okay? Next, two angles are congruent if they are right angles, of course. When we say right angles, these are angles that measure 90 degrees. B, we have vertical angles. What do you mean by vertical angles? So let's say these are vertical angles, they are also congruent. Supplementary to the same angle or two congruent angles. Okay, so when we say supplementary, when you add the two angles, the sum is 180. Then letter D, complementary to the same angle or to two congruent angles. Complementary means when you add the two angles, the sum is 90 degrees. Then letter E, congruent to the same angle or to two congruent angles. So those are the things that we can use, okay, as reasons or proof, because those are postulates. Remember, if we have this bisector here, so segment AC is congruent to segment AC. So we can say that segment AC is common to the other to the two triangles. All right, so that's what we call reflexive postulate. Then if we have vertical angles, angle 1 and congruent to angle 2, because they are vertical angles, and vertical angles are congruent. So that's a postulate. Example 1. So let's now start the proving. Given the given segment AB is congruent to segment AD, segment AC bisects angle BAD. Let's now prove triangle ABC is congruent to triangle ADC. Alright? But before we start with the two column proving, okay, so we have to actually make an assumption if what is the triangle congruence postulate that is actually present here. Okay? So, who can give me the answer? Okay, very good. It is what we call side angle side. Side angle side. So, or SAS. Because this will serve as your guide in proving. Okay? So, you have to make first your assumption. I'm not saying that this is the correct answer, but you have to make your assumption so that you will be guided when you actually write your proofs or your reasons. Okay? And the statements that you're going to use. Let's start. Alright, so given segment AC is congruent to segment AD. So the given must be written under statements. The givens must be present. Okay? So segment AB is congruent to segment AD. That's a given. And of course, segment AC bisects angle BAD. And remember, we are talking about side angle side postulate. So the first side is the first statement. And the reason it is a given. Then segment AC bisects angle BAD. That's also a given. So we need A, we need S. So let's have the A. Angle BAC, so this is angle BAC, is congruent to angle CAD because angle bisector bisects an angle into two congruent angles. These are written in the remember part. Okay? So these are the postulates that I have presented a while back before we start this example. Then this is the A. So let's have the S, the last S. Segment AC is congruent to segment AC. So this is also a postulate a while back. So if this is a common segment, therefore the reason that we can give here is this is under reflexive postulate. So we're done with SAS. Therefore, we can say that triangle ABC is congruent to triangle ADC under side angle side postulate. So as simple as that. You have to remember, first thing is you have to make your assumption. Second, you will be using that assumption or that postulate as guide in writing your statements and reasons. And of course, the given must be present under the statement. Alright? Next, example 2. Given angle M and angle A are right angles. So we have 3 given here. So segment ME is congruent to segment AD and line ME is parallel to line AD. We have to prove that triangle MEY is congruent to triangle ADN. But before that you have to make your assumption so that you will be guided if what is the postulate here. So as you can see, we have angle side angle. Angle side angle. So it means we will be using SAS or side rather it's ASA or angle side angle as our assumption so that we will be guided on how are we going to write our statements and reasons. So let's start. Again, given angle M and angle E are right angles. Okay, so that's the first given. Then angle E is congruent to angle D. So that's the first angle that we can actually use. Then we need S, we need A. Because all interior angles cut by a transversal formed by parallel lines are congruent. So as you can see in the postulates that I have presented, these are what we call alternate interior angles. Then segment ME is congruent to segment AD. That's a given, and this is already our included side. Then line ME is parallel to line AD. That's also a given. And lastly, we need another angle. Okay. so that we can say that we can prove that these two triangles are congruent under ASA. Angle M is congruent to angle A. Right angles are congruent. So as you can see, these are right angles. And right angles are congruent is one of the postulates that I have presented a while back. So therefore, we can say that triangle MEY is congruent to triangle ADN because of ASA postulate, or the angle side angle postulate. Alright, so as simple as that. If you do have questions or clarifications, you can actually contact me on the contact information that I have given you, or you can comment down. Alright, now let's have example 3, second to the last. This is capital R. Given segment QR is congruent to segment ST, segment QT is congruent to segment SR, let us prove that triangle QRT is congruent to triangle STR. But before that, you have to make your assumption. So as you can see, we are talking about three sides. 1, 2, 3, 1, 2, 3. So therefore, the assumption that we can make is SSS, congruence postulate. So that we will be guided in writing our statements and reasons. Let's start. So the first given, we have segment QR is congruent to segment ST. That's a given. That's the first side as well. We have segment QT is congruent to segment SR. That is also a given. That's the second side. And lastly, segment RT is congruent to segment RT. As you can see, we have this one. And this is a postulate. We call it reflexive postulate. So that's the last side. SSS is quite easier to prove than the other postulates. So therefore, we can say the triangle QRT is congruent to triangle STR under or because of side postulate. Okay, next, let's have the last example. Given that angle Y is congruent to angle N, E is the midpoint of segment RB. Let us prove that triangle REY is congruent to triangle BEN. Okay, so but first we have to make our assumption. We have angle, angle side, angle, angle side. Therefore, this is what we call AAS. So very good for those who actually guess if what is the assumption that we can actually use here to prove the congruence of the two triangles. Alright, let's proceed. Okay, so angle Y is congruent to angle N. That's a given, and that's our first angle. And then E is the midpoint of RB. That's also a given. Then, okay, we have the segment or the opposite side. So segment RE, this one, is congruent to segment EB. Why? Midpoint of a segment divides the segment into two equal parts. So this postulate is included in the postulates that I have discussed a while back. Alright? So this is S. And then lastly, we have angle 1 is congruent to angle 2. So vertical angles are congruent. So that's the last angle. Okay, so as you can see, it's not that we can see here that we didn't follow AAS, rather it became ASA. But as you can see, it's the same as AAS based on the illustration and based on the given. Alright, so we can say that triangle REY is congruent to triangle ABN because of CP-CTC principle or postulate, or AAS postulate. Remember that CP-CTC is in relation with AAS postulate. So that's how you're going to prove. Okay, assumption, take note of the given, and then you have to follow the acronym of the postulate in writing your statements and proof. Okay, so for your activity, you will be answering this one. Okay, so we have 4 examples as well, which I will be sending to your group chats. Okay, so I do hope that you have learned a lot about triangle congruence postulate, and thank you for staying until this end. Okay, so don't forget to hit the subscribe and the subscribe button and the notification bell for more videos. Okay, so thank you so much. This is Teacher Dong, and have a nice day to all of you.